What happens if we fall into a black hole? What is a black hole? A black hole is an object with such a strong gravitational field that nothing can escape from it. The gravity of a black hole is so strong that even light cannot escape, and it's believed that if you were to fall into one, your body would be torn apart by the extreme pull of its gravity. Black holes are classified according to their mass: supermassive, intermediate mass, and stellar, i.e., small. Supermassive black holes have masses equivalent to billions or trillions of times more than our own sun. They're millions of times larger than Earth's sun. Intermediate mass black holes are between 10 million tons up to 100 billion tons. Stellar ones range anywhere from 2 million tons up to 2 trillion tons. And those last two numbers don't even include any galaxies with high-density cores like ours here on Earth. The gravity of a black hole is so strong they can bend light. You may have heard that light can be bent by gravity. When you watch a star fall into a black hole, you'll notice that the light from the star gets bent around the black hole and comes out in a different direction. This is because of how powerful their gravitational forces are. The more massive something is, the stronger its gravity field will be. Black holes can't be seen with your naked eye, however. They do emit radiation as well as high-energy particles from within them, called Hawking radiation. This makes them very valuable objects to study. Black holes don't keep their victims forever. After millions of years, they evaporate completely. The black hole will evaporate over time. The black hole will become smaller and smaller. Eventually, the size of the black hole will decrease to nothing and disappear completely. The Earth won't become a black hole if the Sun becomes one. The Sun is too small to become a black hole, because even though it has many times more mass than Earth, it has only about 1/10 of our planet's radius and volume. So what happens if we fall into a black hole? If you're reading this article, and who doesn't, then you might be wondering why our universe hasn't collapsed into one big ball yet. Well, don't worry, it's not likely that there will ever be any kind of singularity in our galaxy or anywhere else for that matter. For starters, most physicists think that as soon as your body gets close enough to the event horizon, the point at which no light can escape, there won't be any air left to breathe, so how would you survive? And secondly, even if somehow someone survived long enough inside one of these things, which seems unlikely, they'd eventually start vomiting up all their food and water due to relativistic effects caused by traveling faster than light speed through space-time itself. Black holes are denser than most things we're used to. They have an enormous amount of mass, and the more mass something has, the stronger its gravitational field will be. In fact, black holes are so dense that they can pull other objects right into them. That's why it's important to know how much material a black hole has before deciding whether or not you're falling into one. If your spaceship is falling through empty space, and there's no gravitational pull, then your ship won't get pulled any closer by anything around it. But if there were another object nearby with lots and lots of mass, then even though you're traveling at super fast speeds toward that object's center point, which would normally take billions of years, within seconds all those atoms would start getting pulled toward each other until nothing was left but one big ball full of energy, a black hole. Black holes have three parts: the singularity, event horizon, and accretion disk. The first is a point where space-time becomes infinitely dense, meaning that no light can escape from it. This happens when a massive object merges with another one so fast that it creates an event horizon, the point of no return. The second part is what we see as the black hole itself. An infinitely dense region of space where gravity is so strong that nothing can escape its pull, including light. It's similar to what happens when two objects merge past each other at high speeds. Their combined mass causes them both to fall through space faster than normal because they're traveling in different directions at once. The third part of a black hole is its accretion disk, a ring. an accretion zone surrounded by matter drawn into the gravitational field, similar to how Saturn's rings are created. The material inside this region does not gain much mass because it is absorbed by our Sun's gravity before falling back to Earth. However, if enough material falls to one side, there can be consequences such as causing solar flares or even affecting the Earth's orbit around our planet. It is true that we have not yet seen a real black hole, but we've seen stars get lost in them, and their effects on other nearby objects are highly variable. For example, when a star collapses into a black hole and then disappears, it leaves behind its outer layers as dust and gas. This phenomenon is called evaporation. The leftover material spirals outward in the form of an accretion disk around the event horizon, the point where light cannot escape, of this new object, until a new star, a much smaller version of our Sun, forms. This means that there are now two sources, one where the item was created, another place where matter disappears into nothingness, or micro-singularity. A black hole is like an all-you-can-eat buffet for space geeks, containing many ingredients that are very strange to the human mind. If a black hole is like an all-you-can-eat buffet for space geeks, it contains many ingredients that are very strange to the human mind. A black hole has three parts: the accretion disk, the inner accretion disk, and Hawking radiation. The accretion disk is formed when material falls into its center and is pulled there by gravity. Then, when you descend into the inner accretion disk, the really dense part of it, the density becomes so high that no light can escape from it, and you are left with just moving particles with no mass or energy. This is what we call zero-point energy. Finally, there is Hawking radiation, also called the quantum vacuum zero-point field, which is caused by quantum fluctuations in spacetime itself. These fluctuations occur when something like an electron is excited by external forces such as gravity or electromagnetic fields, but does not fall into a specific location on Earth because our planet only has a surface-level positive charge due to bonds between atoms on Earth. So what do you think? Do we really have anything to worry about if Earth falls into a black hole? The answer seems to be no. But it's still fun to imagine we could travel there one day and see what it looks like from the inside.